So in this problem, I want to show you how we can find the time that an object is in the air. So what we have here is a ball. It starts right here. It's thrown upwards, and it goes up, 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 and then it turns around and comes all the way back down to the ground. And the place that it started right here was 25 meters above the ground. So since it's thrown upwards, the initial velocity is positive. We don't know the final velocity, but we do know delta y because the ball starts here and it ends up on the ground. So overall, delta y in this case is negative 25 meters. It ends up 25 meters below where it started. Of course, because gravity is changing the velocity, we know the acceleration is 9.81 meters per second squared. And our goal is to find the time, okay? So there's a couple of ways you can do this, but the most straightforward way involves two steps. So the first thing I'm going to do is I'm going to solve this equation, v final squared equals v initial squared plus 2 times the acceleration times delta y. I'm going to solve that for the final velocity. So what I'm really going to do is find out what is the final velocity when it gets down here to the ground, okay? So to do that, algebraically, I've already got v final on the left side. I just need to take the square root. So what I get is that the final velocity is equal to, I'm going to have the initial velocity squared plus 2 times the acceleration times delta y. It's going to be the square root of that whole mess. And we have to remember that when we introduce a radical, it could be plus or minus. So in this case, we have to figure out which answer makes sense. So remember, when it hits the ground, it's moving downwards. So we're going to use the negative as the final velocity here, okay? So we're just going to plug in our numbers, and we just got to be a little bit careful. The final velocity is going to be negative. I'm going to have the initial velocity, which was 15 meters per second squared, plus 2 times a, which is negative 9.81 meters per second squared, times delta y, which is negative 25 meters. And then it's going to be the square root of that whole thing, and then we're going to take the negative of that. So you just got to watch out. You've got a negative here times a negative there, okay? So when you plug this whole thing in your calculator, and you should try it to make sure you're getting this part right, when you plug this whole thing in your calculator, you get a final velocity of somewhere in the neighborhood of about negative 26.7. So negative 26.7. I'll go with one more decimal place. And that's going to be meters per second, and it's got to be negative or you'll get the next part wrong, okay? So remember, when you introduce the radical, it could be plus or minus. You got to pick the one that makes sense. In this case, the final velocity is negative because it's going downwards. All right, once we do that, the second step is relatively easy. Once we know the final velocity, we can solve the final velocity equals the initial velocity plus the acceleration times the time. We can solve that for the time. So the time will be the final velocity minus the initial velocity divided by the acceleration. I'm going to slide this up a little bit. When I plug in my numbers, again, just be a little bit careful. The final velocity is negative 26.75 meters per second minus the initial, which is 15 meters per second. And once you find that, you're going to divide it all by the acceleration, which is negative 9.81 meters per second squared. So you're going to have a negative minus a positive. So this is going to be a negative in the numerator. We divide by a negative in the denominator, and you'll get a positive answer. So make sure you group your numerator and denominator there. And when you do all that, you'll get an answer for the time somewhere around 5.28. 5.28 seconds. Okay, so that's how you solve the problem. That's one of the ways to solve the problem if you're asked to find the time that the ball is in the air. And I should note that the only difference if the ball is thrown downwards, so if somebody throws the ball downwards and asks how long it's in the air, then the initial velocity here is negative. Okay, so this will be negative when you start the problem. So you'll have a negative here and a negative there for the initial velocity, and you'll have a negative here. So you'll have a negative, So just keep track of that. If it's thrown downwards, the initial velocity is negative. If it's thrown upwards, the initial velocity is positive.